What's up guys, Shawnthebro here, and in today's episode of the Fighting Game Tutorial Series, we are going to be going over AI Part 3. This one's a big one because this is where we're actually going to be setting up the behavior tree and assigning that to the controller. So if we come into our game, and I'll go to practice mode because we have our logic set up where we will spawn an AI when we enter practice mode. As it loads in here, you will start hearing a sound, a random clicking sound or like banging sound. That sound is what I told my AI to do in the behavior tree. So the reason for this is because we're going to use tasks to implement our actions in our fighting game AI. They're quite long and quite complicated to come up with, so we're going to create one in the next episode of AI. Right now I'm just choosing a very simple one of just playing a sound effect. But of course these tasks will be things like choose to move to a position, attempt to do an attack, that sort of thing. You can also ignore these subtitles I have here. This is from the previous episode and something I'm building as well, but unrelated to the AI. But that's what we're going to be covering today, so if you're interested in getting caught up in the series and checking out how we did everything in our fighting game, from hitboxes, hurt boxes you see on the screen, projectiles, and a lot more, you can click this icon in the top right corner right here to check out the entire playlist. Alternatively, if you don't care about that and you just care about AI, I do recommend you watch the first two episodes. They're not directly related and you could skip them if you want, but they are going to play nicely with the rest of our AI in the future, especially when we do practice mode behaviors such as crouching, jumping, so on and so forth. I'll link them in the top right corner right here in case you do want to get caught up with them. With that out of the way, we can go ahead and get started. This is a code and blueprint tutorial series. We're going to be doing pretty much everything in the code today. We're going to have to make one small adjustment to our game mode BP, and we're going to create some assets within the editor. But note that we are doing our AI in C++. So the behavior tree is not a blueprint. Really, this is just an editor tool to make things easily for us. You can create tasks entirely in C++, and that's what we're going to be doing, but you can link them together here in this behavior tree. This is highly efficient, really good on performance. It is not a blueprint. We're not losing anything by using the built-in behavior tree. Although it's not required, you can do AI without behavior trees in Unreal. It makes complicated AI a lot easier to deal with, in my opinion. This is a C++ AI tutorial using the behavior tree. Alright, so with that said, we can go into the code. So I'm going to Visual Studio. I'm going back to my base AI controller.h. We made this AI controller, very simple AI controller that had a tick function and some force functions, so we could force the AI to add the jump, crouch, or block input. And then we also added a specific possess pawn variable and a practice state variable. The practice state is tracking what the practice mode AI is doing. None of that is necessary for today's episode, so you can ignore it. What we do want for today's episode is our onPossess and a behavior tree variable. So first one here is a new function, onPossess, and this gets called when the AI controller possesses a pawn. Now we call possess in the game mode already, so when we're in a mode other than versus, we just go ahead and possess that pawn with an AI controller if we've determined that they're an AI player. Now once that happens, this will be called. Note that it is a virtual override function, just like the tick function is. So this actually exists within the standard AI controller, and even above that it actually exists within the base player controller. So it's not a new function we're making today, we're just overriding it. Virtual void onPossess. The parameter is an a pawn pointer called inPawn, and I'm adding my override keyword. Now we're going to need to add the behavior tree include here so that we can make this variable type. So up at the top above your generated.h include, hashtag include behavior tree / behavior tree.h. Now scroll down to your variables. I still have this in private, but you could put it wherever you want. I have uBehavior tree pointer behavior tree, and I made this one a U property of edit anywhere because we may want to be able to change our behavior tree at any point. We also want to be able to blueprint read write so that we can access it and edit it within the blueprint, which allows us to also assign it in the class defaults. Category, I gave it behavior tree, and I gave it a meta equals allow private access equals true. This last one here, you've probably seen me use a few times, but basically what it means is this variable can be private and we will still be able to use this U property edit anywhere and blueprint read write on it. Otherwise they're typically public when you do this, but I'm making the behavior tree private because we will likely want a getter for this in the future. It's going to be very useful to grab this from many areas, and we're going to have different classes with behavior trees as well, so private or protected is a safe bet for now. Now we can go into the base AI controller.cpp, and when we're in here, we can set our behavior tree, and we should set our behavior tree, so I'm going to do that now. Just realized I had this behavior tree as capital because I was using a component before. I was playing around with that. Should be lowercase for me because I decided not to use the component right now, so just regular behavior tree asset. So I'm making it lowercase, and I'm going to set behavior tree equal to null pointer by default. Now we want to make our onPossess function here. Void a base AI controller : onPossess, passing in a pawn pointer in pawn. As soon as we come into the function, I'm calling super : onPossess, and then passing in that same pawn. Remember, all this does is go and call the parent function. So we're in base AI controller, which is a child of a AI controller. So it's going to call AI controllers onPossess. It's because we don't want to lose any of that logic that class does. We just want to add additional logic. Next thing we have is an if statement. So if the behavior tree is valid, we'll say if there is a behavior tree assigned to this AI controller. So if behavior tree, if it is valid, we'll go into the if statement, and we're going to create a Blackboard component. We need to create one because we're going to fill it out with information. We're not doing anything with that yet, but I will show you what we're going to do with this very shortly. So uBlackboard component pointer, default Blackboard equals null pointer. Create a default Blackboard. Okay, then we're going to use the Blackboard. Blackboards are important in Unreal because they bind the variables to the behavior tree so that we can track what certain things are, what values they have, and we know where to go from there. Of course, we're going to have a lot of information on Blackboards in the future, but just know that we're basically toggling this Blackboard on, or saying we're going to use this Blackboard. Basically, we're creating one and using it on the behavior tree. Use the default Blackboard in the behavior tree. Then for this last bit here, I'm calling run behavior tree, which is what's going to actually execute the logic. If we didn't run the tree, then nothing would happen. It's the same thing as like if you have functions that you don't call, they're not going to execute. Running the tree just starts the tree at the root and allows it to go down and actually follow all the elements of the tree. Start the behavior tree. You can try and build at this point, but you will likely get an error because up to this point in the series, we have not included the proper module for AI things like behavior trees and Blackboard. To get access to those things, we need to go to our fightertemplate.build.cs, or basically projectname.build.cs. In here, we have a list of public dependency module names, and we've been adding to them as we've needed them in the series. I'm going to add a comma after my last one here, which is my online subsystem utils, and add a new one today, which is called AI module. Now once you do this, you should be able to build, and then you can go ahead and launch the editor. Alright, the editor is open, so we want to go to our blueprints, and I have an AI folder. In here I'm going to create a few things. I'm going to create the base AI controller BP, I'm going to create the behavior tree, and the Blackboard. So let's start with the AI controller BP, so add blueprint class, all classes, and we're going to find our base AI controller, which was the C++ class. That's going to be our parent. We're going to select that. When you do that, you're going to get this object and you're going to be able to name it. I called it base AI controller BP. Now let's go and add the AI things, the behavior tree and the Blackboard. So add artificial intelligence behavior tree. And I called this one base AI behavior tree. And add artificial intelligence Blackboard. And I called this one base AI Blackboard. Let's go into our base AI controller BP. And we should get to this screen where we can see the class defaults. In here, we should find our behavior tree that we made in the code. We want to set it to the new behavior tree that we're making, the base AI behavior tree. That way, whenever this controller is in play, it uses this behavior tree unless we change it out. Now we want to go into the base AI behavior tree, and it will look something like this. In the details panel of your behavior tree, you will have this AI section and then this behavior tree section, and that should have a Blackboard asset. You can manually pick this, like we're setting it to our base AI Blackboard. We were actually able to create one in the code and assign that one by default upon possession. Either method will work. As we get into more logic here, obviously it's not going to just be so up in the air. I'm going to show you exactly what I'm doing for it. But just know you can either set the Blackboard asset this way, or in the code like we did earlier in onPossess. And you may want to have a default and switch them out from time to time too. Now within the behavior tree, we can actually define logic that we want to occur. Remember, this is not a blueprint. We're actually making nodes that are going to be linked to in Unreal's logic to then execute in an efficient manner and essentially perform an AI task. When you come into your behavior tree, you're going to have this root element. This is where the behavior tree starts, and it is the very first thing that will run. So it's going to start here, and then it will go to the next node that we add. We can drag off of the root state here, or node, and then select our next option. I'm going to select a selector. Quick overview of what these are. They're all commented, so you can highlight over them and see. But a selector is going to execute from left to right, and it's going to stop selecting them when one of their children succeeds. So, for example, if we're trying to perform a task, say we're going to check and see if we're within range to perform an attack. If we're not within range to perform the attack, the task fails, in which case we go to the next one. Once one succeeds, the selector is done, and we go to another set of logic. The sequence is going to go through all of them until one fails. If one of their children fails, then we want to exit out. Right now I'm just making a selector. You get this node here. Don't have to change anything to it, although you can name it if you want, like test selector, for example. Then, as a child of this, we want it to be what we actually want to happen, what logic the AI should actually be going through. Again, for today's episode, since we don't have tasks to test with, I'm going to just have play sound. And then you can come into this node and select your sound. So for me, I just picked one of the random sound effects I had, sc_door_metal_open. But you can change this, of course. So I have my starter content sound. I pick whatever one, and then I can change it to door open sound. Let's say play door open sound. Just like that. Now, once we have a behavior tree set up that is going to be a proper test to make sure that our AI controller is actually running this logic, we need to adjust something in our game mode BP. So go back to your blueprints, go to your game mode BP. In here, we have the spawn players function where we were going through determining if it was player 1 or player 2 based on the start tag. And I was determining what class to spawn based on their selections. After that, I was determining if it was versus, practice, story, arcade, or online. If it is practice, story, or arcade, we are spawning an AI controller. But it's important that we spawn the blueprint version of the AI controller right now, because otherwise, anything we assigned in the AI version of the controller won't be in the code version of the controller. And we created our behavior tree in the editor and assigned it to the AI controller blueprint. So of course, we will need to change the spawn actor from class to be base AI controller BP. Now the rest of this logic is the same. We're going to possess them and set the possessed pawn. This is from the previous episodes. At this point, when you load into your game, you should play the sound effect or do whatever logic is in this behavior tree, because that's what we've set it up to do. So anyway, guys, that's all I got for you. Thank you so much for watching. I'm so excited about what we can accomplish with AI in fighting games, and I'm so excited to be doing it in C++. It's a fun challenge, and it's exciting at the same time. So thank you guys for watching. If you enjoyed, please subscribe. It does more for myself and the channel than anything else you can do, and I really appreciate that. I want to give a huge shout out to my YouTube membership, Discord subscribers, and Patreon members. You guys are awesome, and you support the channel so incredibly much, so I want to thank you very, very much for that. If you ran into any problems while following this tutorial or any of my tutorials, feel free to join the Discord community. I'd be happy to help, and that support is completely free. Anyway, guys, like I said, that's all I got, so thank you so much for watching. I'm Shawnthebro, and I'll see you in the next one. Goodbye, guys.